All right. We're diving into a fascinating field today. Surface engineering. You've sent over some really interesting stuff, articles, guides, even some interview prep materials. Looks like you're ready to go deeper than just, what it's all about.
Yeah, there's definitely more to it than meets the eye, that's for sure. I think a lot of people they don't realize just how much, well, how crucial surface engineering is to almost everything around us.
I'll admit, I was surprised too when I started looking at everything. So
Mhm.
much more to it. Um, so how would you explain, I guess, for anyone who might think it's just about making things look all shiny, what's a better way to think about what surface engineering actually is?
Well, you could say it's about solving a problem that's as old as time itself, wear and tear.
Okay, I like that.
Yeah. So, like, take metal, for example. If you just leave it out, what happens? It rusts, right? Gets all scratched up, and eventually it breaks down completely.
Makes sense.
So surface engineering is all about, well, it's about finding those, ingenious ways to kind of fight back against that, make things last longer, make them perform better, just be more resilient overall.
It's like giving everyday materials their own superpowers.
Exactly.
And speaking of super, this RoleCatcher career guide we have here, it paints a pretty interesting picture of what a career in surface engineering could actually look like.
Oh yeah, absolutely. It's a field that really combines, really solid science with this creative problem solving side. You need a strong background in material science, chemistry, of course, but also that spark, that spark of innovation to actually to come up with new solutions.
Right, and it's not all like lab coats and beakers, is it?
Yeah.
This guide mentions, everything from hands-on experiments with like really cutting-edge technology to leading these huge research teams and projects. That's quite a range.
It really is. And that's what makes it so rewarding. You could be in the lab one day, testing out a new coating, meticulously going over every detail, and then the next day you're presenting those findings to important stakeholders,
Yeah.
explaining the impact of what you discovered.
Mhm.
It's that blend of, detail-oriented work with big picture thinking that really defines the field, I think.
One thing I noticed going through all this material, it really stood out to me, was the connection to sustainability.
Oh, absolutely.
It seems like it's like woven into surface engineering in a really interesting way.
It's a crucial aspect, yeah. Especially now, it's becoming more and more important. And, it makes sense if you think about it, right?
Yeah, how so?
Well, if you're increasing the lifespan of all these materials, these products, it means we're reducing waste,
Makes sense.
less demand for new resources.
Right, right. So it's like it has this chain reaction, a
Exactly.
positive impact across the board.
Exactly. Think about it like turbine blades. In a wind farm, right? They're
Yeah.
constantly being bombarded,
Right.
right? Wind, rain, even those tiny little particles in the air can cause erosion over time.
Oh, wow.
But by using these specialized coatings, that's where surface engineering comes in.
Right.
They can make those blades last significantly longer. And what does that mean? Fewer replacements, less downtime, and overall, a lower environmental footprint for renewable energy.
Wow. That's amazing. And it really drives home the point that surface engineering isn't just about making things last longer, right?
Right.
It's about making them last longer in a way that actually benefits, the planet as a whole,
Exactly.
which I love.
And that actually leads us into, another area I know you were curious about, the whole interview process,
Oh,
right?
right. Yes, yeah.
For circus engineering roles.
Because the RoleCatcher guide, they actually gave us some real life examples of interview questions.
Mhm.
And I got to say, some of them, they really got me thinking.
Yeah, they're designed to, well, they do more than just, test your knowledge. They want to see how you think,
Oh, interesting.
how you approach a problem.
Okay.
Like, for example, one of the questions is, how would you go about improving the scratch resistance of, let's say, a smartphone screen?
Okay, well, that seems, I don't know, kind of straightforward. Wouldn't you just, like, need a tougher coating?
Well, yeah, sure, but it's not that simple, right?
Right.
You need a tough coating, yes, but it also has to be transparent.
Oh, of course.
It's got to adhere to the glass properly. You got to think about the manufacturing process. And of course, you got to keep costs in mind.
Right, right. All these factors.
So they're really looking for, can you think it through? Can you analyze the problem from all these different angles?
So it's more about showing them, like, your problem-solving process,
Exactly.
not just, like, knowing the answer.
Exactly.
Okay, that makes sense. What about that other question about having to solve a complex surface engineering problem? I feel like they're asking for like your origin story almost.
Yeah, kind of. And you know what? It actually reminded me of this project I worked on pretty early in my career, actually. We were trying to develop this coating to prevent corrosion in pipelines, the ones they use for offshore oil drilling.
Wow, that's quite the story. Sounds like you had to get really creative to solve that one.
Yeah.
It makes me think about, well, all the different kinds of materials this field actually works with. I mean, we've talked a lot about metal, but it doesn't stop there, right?
Oh, absolutely not. Surface engineering, it's applied to, well, pretty much everything. We're talking plastics, ceramics, even textiles.
Really?
Yeah, think about it. Like how do they make fabrics water repellent? Or those antimicrobial coatings they use for medical devices. That's all surface engineering.
Oh, wow. I never even thought about that.
Yeah, it's about, taking those existing materials, enhancing them, but also creating entirely new ones, with properties that we could only have dreamed of before.
It's pretty incredible when you think about the possibilities, what could be done. Going through all of this, it strikes me that surface engineering, it's almost like this, I don't know, this hidden force shaping so many parts of our lives, and we don't even realize it.
It really is, and that's why it's important, even if you personally aren't going to become a surface engineer yourself,
Right.
it's a field that has this ripple effect.
Mhm.
It's pushing for a more sustainable future. It's right there on the cutting edge of new technologies. And honestly, it's changing the world around us in really tangible ways, one surface at a time.
It really is amazing. I love that. It's like well, I was going to make a pun and say, we've only just scratched the surface, but I'll spare you this time.
Well, it's true, though.
Yeah, it's true.
There are constantly new materials being discovered, new challenges popping up, new possibilities emerging all the time. It's really a field that's all about constant discovery.
That's so exciting. It really is. Well, for you, dear listener, we'll leave you with this thought. What everyday object would you want to improve using surface engineering? A phone screen that could never crack no matter how many times you drop it. What about self-healing paint on your car? I mean, the possibilities are really endless. And who knows? Maybe you, our listener, you might be the one to revolutionize the field next. So keep exploring, and we'll catch you on our next deep dive, where we'll be taking a closer look at a whole new and, of course, fascinating topic.